today is Amanda Brock. She's CEO of Open UK, an executive producer state of OpenCon, and Amanda's 25 years of legal experience include being instrumental in shaping open source legal frameworks and internet law in 2000s. Sought after international keynote speaker, tech trends contributor, and editor of open source law and policy and practice. Amanda will tell us all about AI openness today.
Good morning, Bangkok. Well done to those of you who've come here very early this morning. I very much appreciate you joining me. So I'm going to talk to you a little bit about AI openness. Before I get there, as the lady who introduced me very kindly said, I edited a book, which is probably the worst thing I've ever done. It's very hard work. I had 26 authors, it's 640 pages long, and I'm not trying to sell it to you. You can download it free using the QR code. If you look at it, you're going to be very disappointed because there's nothing in it about AI. And there's nothing in it about AI because we set the book 7 years ago. So when we do the next edition, obviously AI will run all the way through. But 7 years ago, we thought AI was irrelevant. And I lead an organization called Open UK, which is a country organization, a policy organization. We bring the community together. We do legal and policy work to try and influence the government to have good laws for open source in the UK. And then we collaborate globally, which is why I end up coming to things like this to meet all of you in a city like Bangkok. So thank you very much for having me. And this might not be where you expect the day AI to start. But I think it's really important that we think about open source when we talk about openness in AI. And the starting point for that open source is understanding what we mean by open source software, right? And we've all known what open source software is for almost 30 years because we have an open source definition that is established and accepted. And what this definition does is set the base for our licensing of open source software. So open source software is software which is distributed on a license that complies with this definition. Now, I often joke that we should all recite it together because I can't do it and none of you can do it. Nobody knows the exact terms word by word. Even Bruce Perrins, who wrote it, I've sat with Bruce and he's been looking at notes to check what it says. And I think for everybody, there is something different that is really important to them. So the distribution of the code on these licenses is very important. But for me, the key thing about it is 5 and 6. And what 5 and 6 effectively say is that anyone can use that software for any purpose. There is no restriction. Now, that doesn't mean that laws won't apply. Laws override or trump the licensing. But 5 and 6 mean that you can rely on a free flow, that when you get open source software, you can take it, you can use it for any purpose, so long as you're doing something legal, and you don't have to worry about any licensing, any additional payments, anything else. There is this beautiful free flow, and that free flow is what's caused the adoption in the ecosystem. It's what's caused the pace of open source adoption in the last 5-10 years, where today we see 96% of software stacks having dependencies on open source. We see 76% of all software that's used in the stack being open source. Now, there is a challenge with this free flow, and that challenge with the free flow is generally around commercialization. And the challenge is working out, if you use open source as the basis for a commercial business, how you monetize it, because open source isn't a business model. It's a way of licensing software. It's a way of creating software, but it is not a business model. And what we've seen is friction introduced into that free flow by terms that restrict commercialization. And we often see this in companies as they grow, as the IPO, as the VCs want them to make more money. It's not that they're not making money. So companies like Elastic, when in 2021, Shay Bannon shifted Elasticsearch away from an open source license onto SSPL. When that happened, they were very profitable, but they thought they could make more money by being non-open source. And what we've seen in the last year is research that shows that actually they don't know if they are making more. It's unlikely that they are. However, what you see here is friction And that friction, a term that says you cannot use this code commercially in certain situations, interrupts the free flow. And that's super important because if somebody implies that the code is open source and it's not, effectively what you're doing is open washing. Now, open washing is when you imply that it has this free flow, when it has the open source goodness, but it doesn't really because the friction is in the supply chain, in the ecosystem. And open washing is a term that I never thought we would see in the mainstream. And then last year, both The Economist and the New York Times actually wrote about it. And they wrote about it because of AI. So what's happened in the last couple of years? Well, in March 2023, the conversation about open source became relevant, so 2 years ago. And in those 2 years, what we've seen is ChatGPT-4, which was not OpenAI, despite the fact that the company is called OpenAI. That's the biggest misnomer, the biggest confusion in history. Although OpenAI was originally set up to be an open source not-for-profit, and Elon Musk claims that that has a lot to do with him, by the time GPT-4 was released in March 23, it was very, very much a closed piece of software. But what it did was start things moving. So we then saw Llama, the first Llama, released openly for research purposes. So not open source, but released with a restriction around how it was used. Wouldn't make the open source software definition. But it was leaked. And when it was leaked, what we saw between March and May was a pace of innovation that was unprecedented in AI. And what we saw was this leaked memo from Google, which I think sums the whole thing up beautifully. We saw the big techs who'd invested millions and billions of dollars realizing that they could not compete with the open communities if you gave them the tools, that the innovation that the open communities would do was faster through its collaboration than anything big tech could do. And what they said is we have no moat. And when they say moat, they mean the water around a castle, the moat that protects it so that it, I have no slides, I do. So it's the moat around the castle that protects it, that stops people coming through. And usually in tech, that's intellectual property. It's the way you protect your innovation from others. And what they were saying was we have no moat. We're unable to protect ourselves from the open communities because their innovation is so good. We cannot finesse our products enough to be able to sell them in competition to that open output. So by July, we saw Zuckerberg being questioned about this. And then we saw Llama 2 launch on a non-open source license. Now you'll see open organization's logo there. And we were the only open source organization to support this. And what we supported, because we have a broad remit that isn't just open source, it's open technology. So software, hardware, data, standards, AI, everything that's open. And when we supported this, we signed up to a statement, as everybody who was working on Llama 2's launch did. And you will see the words open source are not used there anywhere. They called it open innovation because it has restrictions. It has an acceptable use policy, and it has a restriction on 700 million users or more. Now that creates a friction in the supply chain, but it also means for Meta that whoever wins, they win. Because anybody who gets 700 million users or more has to go back to Meta and get a commercial license. Despite all of that, I and my board think we did the right thing because this release was so significant and what it has then led to. It moved the needle forward. It changed things in AI. So if you're interested in more, I wrote this piece about why it's not open source. But then we see in January 2024, I think the next most significant change with the launch of R1 from DeepSeek. Now that is on an open source license, at least the weights are, but it was created by distilling existing open AI. So Quark and Llama 2 were used as the basis for this. If Llama 2 had not been distributed openly, DeepSeek R1 would not have happened. So that's super important. And when you look at R1, what you see is a 5 million cost for something that previously had cost 100 million. So it took the market down. NVIDIA's share price went down 17% in 24 hours. It shifted things. And that impact, although we see a settling again afterwards, that impact is super significant, because what we see Sam Altman saying that he's on the wrong side of history. I'm going to have this printed on a t-shirt and wear it everywhere I go, because this is super important. The wrong side of history when it comes to open weights. Now, what you'll notice is that they're not talking about open source here. They're talking about open weights. And things start to change, and we start to see more conversations about that. Following DeepSeek's R1, almost immediately, Hugging Face take those open weights and try to work out what was going on. How did they get here? And they use the instructions that were also openly shared with different data to reproduce a truly open version. And then we saw, like 2 weeks ago, I think, I'm losing track of time, DeepSeek then shared a number of different tools that help to build more openness in AI by sharing a repo each day that was truly open source, all shared on an MIT-approved license. But what we've seen over the last couple of years, whilst all of this innovation has been happening even, we've seen a huge battle going on about what should and should not be called open source in AI. And we've seen the Open Source Initiative come up with a definition, which was published last October. People have very different views on that. Their views, I guess, cause friction in the ecosystem. It's not necessarily a good thing. And it hasn't had a massive scale of adoption. We then see the Free Software Foundation also creating a definition of their own. And we see more and more talking about the confusion that's being caused. So my personal view is that there's a better approach, and that better approach is to look at the component parts, look at the weights, look at the data, look at the different aspects of AI to see which pieces are open, whether they're partly open, fully open, or closed, and what that means. And that allows you to do a better risk assessment. In the meantime, we've seen the policymakers and the regulators try to understand what AI means, but also what openness means. And we saw the EU in May last year create the first AI legislation. And then we saw in October last year, the White House under Biden create this executive order, followed swiftly last summer by more confirmation that open source was good. And then in January, this is Biden's executive order gone. So Trump's administration has shifted things. We're expecting a new executive order in the next few months, but nobody knows what that will say. China, like the UK, is working on IP. For the last 18 months, we've seen the UK play quite a significant part. We hosted and set up the first AI summit focused on safety. Last May, we open sourced something called Inspect, and Inspect is the first major tool around governance of AI that's been released. And it's an evaluation platform from the UK's what was called the AI Safety Institute. We saw Rishi Sunak, the then Prime Minister, support that, saying the UK supports open source and we won't legislate. And then a change in government. And that change in government led to a proposal for legislation. We haven't had legislation. We have had an Opportunities Action Plan right before the Paris AI Action Summit. And this is a report. I was, I think, one of two people from Openness who were invited to the summit who didn't work for big corporates. So I was there and the lady from Luther were there. So this report tells you about what went on at the summit. And what we saw was a shift to France as a leader in AI openness in Europe from the UK, but working quite closely with the UK. However, the UK did not sign up to the summit declaration and the US did not. And immediately afterwards, there was a shift from safety to security. And it's really notable that the UK, it's very closely aligned with the US on AI, has not produced its legislation. And I know that the regulators were expecting to share it in December, but I think that's because of the shift in what the content will be. At the summit, we saw two important open source things shared. We saw Roost, which creates more of these governance tools for open source, and they use the strapline tools, not rules, and they focus on having technical solutions for open source problems. And we saw Current AI, which was launched with $500 million and is looking to have $2.5 billion in the next 5 years. Importantly, this index, if you haven't seen it, Tortoise shows the status of AI openness globally, and it shows that France and these initiatives around the summit have pushed ahead to become Europe's #1. But I don't worry too much because the UK still has more GitHub accounts per capita than any country in the world, and over 4 million accounts, and the biggest contribution to open source. And I think the one thing that I would ask you to take away from my brief talk this morning is Sam Altman's quote. Yes, I will print it on a t-shirt, but more importantly, the CEO and founder of the biggest closed AI company in the world thinks he's on the wrong side of history when it comes to open source, and that he should have at least an open weight strategy. If any of you are based in Europe, do join Open UK next year at our State of OpenCon, and you can contact me here. Thank you very much for joining me.
Okay, thank you for that. Our next speaker for the day is Harish Pillai. And Harish Pillai is an ethical technologist with extensive experience in the software industry. And today he will be talking to us about open data for accountability.
How do I share this? There's the text. The PDF here. This one? Are you getting the slide? No. Okay, sorry. He's here. He was the one. Over here. Well, good morning. Where's the mic? Sorry. All right. Okay. Well, good morning, everybody. My name is Harish. I'm here to talk to you about open data for accountability. And thank you, Amanda. Where is she? She's left. So thank you, Amanda, for setting the stage. I wasn't privy to her content before, and so I'm trying to now adjust my content to what she had said. I'll add to that. So I'm with an organization in Singapore called Straits and getting people to understand how do you use and behave in a ethical manner from a privacy and data protection perspective. So they provide training for data protection officers and stuff like that. And it's been around for a while, and they have added a component which allows you, in this case, 80% of people who are not techies, to be able to create generative AI solutions safely and deploy it for your own purposes. So that's what the business does. But I'm not going to talk about the business. I'm going to talk about this particular topic, which is open data for accountability. So let me just bring us through to first principles. I will go through these 5 bullet points as I walk through that. Just hear me out. So what's the first principles? How do we build software? Or I assume most of you has done some kind of software building, compiled my Hello World once before. So you have done that, all right? We all have done that. What do we do? Oh, the image is missing. So what do? We take the source code, we go through a compiler, and the compiler spits out a binary, and that's what we use. We understand that. No magic here. Very clear, very obvious. I'm not sure why the images are missing. Then, how do we build open source software? It's the same way. No difference. Proprietary software, open source software is built the same way. The source code compiled into a binary, and then you run the output, the binary in this case. We understand that. We have figured out how this works for many, many years. Now, how do we release open source software? Well, we add an open source licensing to it. We specify what the code is, what rights you have as a consumer of the code, what can and you cannot do with it, right? So in this diagram, I add that little box there to the source code. When I release it, that tells me that subsequently you as a consumer and receiver of the source code, these are the rights that you have with the source code, the open source licensing. Very clear. We have been doing this for 28, 29 years now, and it is well understood. Now, what do these open source licenses comply to? The open source definition, which is what Amanda shared earlier. She said there are 10 points to it. Exactly. There are 10 of them. I listed it here to help her out because she put in all the additional words behind each of these bullet points. Important thing to remember, and I think she highlighted here, I think that's very useful to think about, is number 5 and number 6. No discrimination against persons or groups. No discrimination against fields of endeavor. So if you create a piece of software, say a vision processing tool for playing games, you cannot restrict that vision processing tool to be used in a military situation or a conflict situation, because that's what this rule says. This is what this principle says. Among many other things, very importantly, these are the 10 open source definition principles that we have to adhere to. Now, all of this, 10 is too much to remember, right? You can't remember all 10. But it has been distilled very nicely and encapsulated in the 4 freedoms. What are the 4 freedoms? It's right there. Freedom to use, freedom to copy, freedom to modify, and freedom to distribute. Now, all the additional details, you go back and refer to the 10 principles. Very clear. We understand how this works. No issues. Is anybody who doesn't understand this in this audience? I hope not, right? We have been doing this for so long, I think everybody knows that. Put another way, the previous one was about freedoms of free software. And in 1998, we added an additional terminology called open source. From my perspective, open source is the marketing term of free software. Why do I say marketing term? It helps keep the VCs and people like that happy because they don't like the word free. So because in English language, free is a problematic word, right? And so open source removes that problem a little bit, but not sufficient because it forgets the freedom part. That is the criticality. And I want you to remember that every time you come across a situation with free software versus open source software. It's the same, but different. Okay. So if you want to couch the 4 freedoms in open source perspective, the open source way, you create, you share, you collaborate, and let everybody do the same. This is a very marketing phrase, marketing set of terms. No issue, we understand, but it maps very clearly to the freedoms. It allows us to do permissionless innovation. That's what has led us so far. You can take anything you want, use it for any purpose, no restrictions. And if you make a mistake, well, sorry, I made a mistake, go and change it. Make it better, or stop the project, or do whatever you want with it. No permission is needed. Now, let's switch it. How do we build and release AI software? Okay. And specifically, generative AI software. How do we do that? Same model, but there's an extra box. As you can see in the middle, you have the code, you have the compiled output from the model source code, and then This part here, the third box, it is the training data. The model then reads the training data, and the training data then creates the final output, which is what you and I will engage with the large language model. Everybody understood this part? This is the flow, okay? I'm actually taking a lot of additional details. I want to simplify it for the purposes of this talk. There are a lot more details, but at a high level, this is approximately what it is. And this is very clear. We understand this. No issues. This is for generative AI, any type of them. Now, if I want to have open source generative AI, what do I need to do? Sure, you can have an open source license like we saw earlier attached to the model code. But then now, what is the component, what is the artifact that you and I are going to be using? We are not going to be using the compiled model code itself. I need to use the model that was generated based on that code. That's what I'm using. I'm not using the one before that. And that's the problem we are faced with. The problem of access or understanding what the data that was used to train, what access rights or lack of them do you have? And so things like you may have come across some of the data sources, books 1, books 2, Common Crawl, the internet. I put a whole bunch of question marks and exclamation points. Who knows what's inside the training data? Do you? That's an important thing. We know what's in the source code, but do you know what's inside the training data? So what does the open source AI definition have to say about this? This is what was Amanda alluded to earlier, last October, officially released by Open Source Initiative. Thank you very much for doing so. What does it say? So I'm taking screenshots from their page. I didn't redo this, I just took screenshots. So you see the 4 boxes in the middle. Use, study, modify, share. Exactly the same as the 4 freedoms. Perfect, right? Pretty much the same. So that's great. So let's see. It looks good because it's consistent with the data part, the code part. But what about the training data? Now, this is where I have a problem with this definition. The definition is insufficient from my perspective to address the data that is used to train the models. Now, going back to why I say that is important, that box there, open data license, there's nothing in the OSAID that specifies what type of data license should you be using. Okay. This is the wording on the page. The page URL is at the bottom. It's opensource.org/AI/open-source-AI-definition. This specific paragraph is what I am concerned about. And this is what I want to highlight to you. And I took the additional components I added there. That's my additions. It's not in the original text, the red and the underline underscored stuff. So it says here, let me read this to you. The preferred form to make modifications to machine learning systems. The preferred form must include all of the elements below. I only showed a couple of, only one set of elements here. There are 2 more after this. But this is the only one I'm interested in. The rest of them are fine. Data information, sufficiently detailed information about the data used to train the system so that a skilled person can build a sustainable, substantially equivalent system. You've got many flags here. What is a skilled person? Who defines the skilled person? I don't know. Is it important? Maybe, maybe not. I don't know. Sufficiently detailed information. The first underlined red 3 words there. What is sufficiently detailed? I think that's a challenge. I don't know what that means. Can build a substantially equivalent system. Substantially, is it 90% substantial? 75% is substantial? 50% is substantial? What would it be? So there's a lot of verbiage here, and we are all computer science people, people who want more specific stuff, this is too fluffy for me. It's not hard and fast yet, okay? Then if you go down to the second, the second sub-bullet there, it says that in particular, this must include complete description of all data used. Do we know and do we have a complete description of all data used? We may or may not have, I don't know. If a model says they have all that, they publish it, maybe you can. At first instance, they tell you what it is. Can you get to it? Because remember, in modifying source code, you need to have source code to start with. Otherwise, I can't modify it. So how would I know, right? And this point number 2, a listing of all publicly available training data and listing of all training data obtainable from third parties and where to obtain it, and including a fee. So this is the first time we come across a statement here that includes access to non-public data. And if you have access to non-public data, there may be a fee you have to pay for that. Now, all of this puts a lot of friction in the system. It is not as free flow as the original open source definitions were and continue to be, specifically for AI. These are some of the constraints that I think we have to address and face and make sure that we come out of it in a better way. Now, I recognize a few things. Not all training data can be shared. Medical maybe not, financial maybe not, personally identifiable information may not be able to be shared. I understand that. Let's address those things. Not all data can be published. Even if I can share it, I may not be allowing you. I can share with you, Mr. Hospital AI engine, but you cannot publish it after that. Okay, so there are constraints. And not all data has rights that have been established. I don't know what the rights are. Whether can I use it? Can my other organization use it? Can I leave it in a public repository? What are my rights? And for every single data source, there may be different constraints. There are too many variables here. So, in my view, OSAID version 1 does not meet the 4 freedoms as of yet. This is my view. This was announced in October last year. From my point of view, it does not meet it. So what is my proposal? My proposal is this. Let's rename version 1 and call it the lesser OSAID. Why lesser? Similar to the LGPL, GPL debate that was in the 1990s. Lesser GPL says you may include this code in your subsequently proprietary piece of code because it's a library code that you're using. So the LGPL addressed that constraint. Then I'm proposing is that we have a OSAID version 2, which is fully open. All data sources must be published. I have to have access to it. I should be able to train my binary that was created from the model code to then generate the final LLM itself. So you follow my argument in this case. This is my rationale and this is my proposal. Whether this will be accepted, I don't know. I need to rally around people to say, hey, shall we do this? Because to me, this seems to be a less of a problematic path to go down instead of worrying about all the various components I need to figure out. Call it lesser lesser OSAID. Fine. Then we know exactly what we're dealing with. Instead of currently it's a bit fluffy. May or may not be. Are you sure of the rights? Maybe you don't have the rights. Can I do this? Can I not do it? And so on. So going back to this model, what would that mean? The open data license, there is already existing work that has been done and data licensing models and verbiage and methodologies has already been published by the Open Knowledge Foundation. We don't need to reinvent the wheel. We are open source people. We copy and paste. Okay? Good ideas are good ideas. Let's just work on that and build on it. So for full accountability, you need to have complete access to the training data. If not, you do not have accountability. You don't know what the training data was used to train whatever you trained on. Let me give you a thought experiment. I got how many minutes left? 3 minutes. Okay. Okay. This is a good thought experiment. Think about this. This is the year 1899. I know none of us were born. Was anybody born in 1899? No. I definitely wasn't. Okay. Yeah, maybe. Maybe somebody is here. I don't know. And OpenAI was around in 1899. And they trained their chat GPT on the data as of 1899. Okay. Now you query against that model and say, okay, can you tell me whether women can vote? What do you think the model is going to tell you? As of 1899, I don't think women could vote. I may be wrong in the date, but it doesn't matter. Just follow through for the idea. Okay. It's in the training data. That's what I'm trying to hint at. It's the training data. The training data stopped at a particular date. Meanwhile, humanity, all of us, I think we are members of the human race, right? We moved on. We have people who can vote. We got all kinds of other things that happened since then. But if we were only going to use the model from 1899, the technical term here is we are screwed. Okay? So this is a thought experiment I want you to always go back to and see if you do not know the provenance of the training data, we do have a problem to call it open source AI. I don't care if you call it proprietary AI. That's a completely different problem. That's not my concern. Our concern here is to be true to our roots, that open source means these things, and it's no two ways about it. When there is a problem, my suggestion of a lesser OSA ID may be an option. Thank you. Yes, questions? Yes, go ahead.
Yeah, I just have one question. Sorry, I attended late. I do agree that these models are, especially the definition, like a kind of success. But my point here is that you are comparing lesser with AI with NGPS. Now, with NGPS, I still have the freedom. I can replicate a particular open source project, and then I can, if I'm making modifications to it, then I need to configure back. That still fits with the open source principles. With this definition, where the training data is not available, a model is calling itself open source. I can't exactly replicate the model. That is one of the challenges with these. So even with lesser OS AI, I mean, it's still not open source. So that's one of the
thank you very much. So for the purpose of the recording, the question here is, my suggestion of a lesser OSA ID is not quite the same as lesser GPL, because you can still do stuff with lesser GPL. I completely agree. This is a suggestion. We have a problem. Let's solve the problem with what we already know that has worked. And based on what we know that has worked, what can we now do from that? Now, it may very well be this is a completely new kettle of fish. We have no choice. We have to take that particular path. But the path that we are currently on, I feel, is the wrong path. That's really what I'm saying. So let's take good ideas from previous iterations of ideas, blend it into this newer way, and see what works, and tweak as little as possible. I don't want too much tweaks, because you know what happens when you have to tweak so many times? You forget what was the last tweak. And eventually you go down a rabbit's hole and you have no idea what you need to fix. So the less we fix, the better it is. Based on what we know, I feel that the lesser GPL, lesser OSA ID is a viable model. Okay. So thank you for your question. I appreciate it. Anybody else? All right. Thank you very much. All right. There we go.
Thank you. And next, upcoming, we have Michael Kristen. He is a long-time open source developer with over 20 years of experience building tools for the FOSS community. As a maintainer of YACY, a decentralized search engine, and Susi AI, an open source conversational AI, he cares about open knowledge and DIY tech. So today he'll be telling us how to practice with self-hosted LLMs and developing LLM agents.
So, hello everybody. This is more a workshop than a talk. So, when I wanted to do this talk, I presented it as workshop, but in the calendar it's now given as a talk. But I want to have it as a workshop. So you can take out your laptop and do coding with me today. I attended some other talks and I've seen a lot of examples where people show how to use LLMs and AI and chat applications in Google Colab. So I wondered a little bit why this is the best example, because this is a cloud application. It's not running on your computer and it's not even free software. So if you are attending at a free software conference, you should take care that everything you are doing is running as free software. And that means on your own device at the first place. So sometimes there is the impression that AI and chat applications and large language models need so powerful hardware that it's of course only possible to do this on a cloud device or using an API. But that's not true. There are so many frameworks and small models and capable models that you can easily run this on your own computer. So if you have 8 gigabytes of RAM on your device, you can run all the examples I will show you, and you don't need a GPU. It's running on CPU and it's running fast on CPU, and you can do small applications and small example applications. So let's start with the idea what I want to do. The framework we are using is Ollama. Ollama is a framework around Llama CPP, and Llama CPP is the first framework which appeared when the Llama model leaked 2 years ago. So it appeared almost instantly. Within a week, someone coded this kind of client for a large language model, which was published by Meta, not on purpose, but later on purpose. And many more models appeared after this. And there are large repositories for large language models like Hugging Face. And I want to show you how to use this. Yeah, I don't think I need the microphone because in some minutes I want to sit down and do some coding, and then I don't have a free hand to use the microphone. So I think we don't need the microphone. So thank you. I hope you can understand me also at the end of the room. The recording is here. I hope this is working. So I also prepared a repository for the example script. So I want to show you how to download the framework for large language models. I want to show you how to download the large language models, not only framework, but also the models itself. And I show you how to download the example scripts we want to try now. So what we are going to do is we go to ollama.com, and I want you to open ollama.com right now and install Ollama right now. And when we have done this, we want to use a model, and what we are using is Llama 3.2. It's a model with 3 billion parameters. So for example, ChatGPT 3.5 was 175 billion parameters. This has only 3 billion parameters, and it's a quantized version with 4-bit quantization. So what does this mean? If you have a model, it's a large number of weights, and these weights are floating point numbers. They have precision usually with 16 bits. But if you want to have a smaller model, you can have the same number of weights, but with less precision. So this is called a quantization. You take the 16-bit precision and remove, for example, 8 bits, then you have an 8-bit precision. And you are losing some intelligence when you're using this model. But it's not a lot. And you can even make this much smaller. You can have a 4-bit precision of the floating point numbers. And it's even with the 4-point precision very capable. This means that a 3 billion parameter model doesn't need 3 gigabytes of memory. In this version of the model, it uses only 2 gigabytes of RAM. That means even if you have only 4 gigabytes on your computer, you can run this. You can run this model on a Raspberry Pi, even on a small Raspberry Pi with only 4 gigabytes of RAM. And that's what we want to do. We want to run software on your own computer, and even on small computers have AI on it. We don't need cloud service. So are you downloading olama.com right now and running it on your own computer? Because we will want to do this now here on my computer. So I show you quickly what happens afterwards. You go to my repository, it's at GitHub, Orbiter LLM RAG cheat sheet. I called it a cheat sheet for AI applications. And I will show this to you later on the web page, and we will do some applications with this. I hope you know how to clone a repository. It should be easy. And then we make the most simple applications, because if you want to use something that you want to understand, so what I do is I start with the most simple program that doesn't use any API if possible. So this is a kind of a hello world application to an API. If you just use the most simple thing to access an API, and that's a curl command. Okay, now let's go step by step through all the things we need to do this. So first thing is, yes, olama.com. So I think you don't need to sign in. You don't need to sign in. Just click on download and use the framework for your own computer. And what happens then is that you get, can you read this? So Olama is not an application with a graphical user interface. It has a command line interface. And it works like this. You type Olama and then a command. So for example, if you have downloaded models, you write Olama ls. I have a lot of models already downloaded. And what you want to do to start with my examples is Olama pull Llama 3.2. And because I already downloaded this, it's just looking if I have the latest version, and it's already done because I already have this here. This is Llama 3.2 latest. So how do you know which kind of model you should download if you don't want Llama 3.2 or maybe a more capable one? So on this web page, you have the option to click on models, and then you get a list of models. Here you have, for example, one of the best working models, which is really intelligent, really good, should run on most of your computers, is V4 from Microsoft, published as an open source model with a proper open source license, I think. Yeah, it has MIT license. And this model card shows you what you get. And for example, here you have tags. The tags show you which kind of model you get. So you can have a 16-bit precision model, or you can have the 8-bit precision model, or the 4-bit precision model. And there's also the short version to name this. The V4 is, like it's documented here, it's the 4-bit precision model if you run this. So you can just click here, copy this to your command line, then you're downloading the model. Oh no, I'm running the model right now. And you can say hello world. Hello world. And it's running quite fast on my machine. What is FOSS? Let's hope it knows what it is. So another place where you get models is Hugging Face. So these kind of models that Llama CPP, which is the engine behind Ollama, is running are so-called GGUF files. And if you click on models on Hugging Face, you get the list of models sorted by most popular right now. And I like to do filter with GGUF, so I get only GGUF. Encoded models. So let's see, maybe you want to have Gemma free 1B, like this. Model files are in files and versions. Here you can see how large they are. So the 4-bit quantized version is under 1 GB. And if you want to install this, you click on use this model right here. There's the option Ollama. You click on Ollama. You get again an option to select the quantization version you want to have. You just click copy, and that will run the full method and run method to run this on your own computer. So you can always keep up with the latest models which are published. You see which one is most popular and so on. So you have access to a large set of good working models. You know that they are open source and you can use this in your own application on your own computer. So let's see how to actually do this. And I want to suggest that you download or clone my repository with the examples for it. So you go to GitHub, to my account, which is Orbiter. No, that's me. And I prepared a repository here. So you just click on the LLM RAC cheat sheet, and copy the code by using this link to clone it. Okay? Are you on it? Do you need more information? Okay. So let's see what we have there. So I open Visual Studio Code where I have cloned this repository. Is this big enough? Maybe this is a bit better. Okay. And in the API example folder, I have named these files in such a way that the order of the lexicographic order of the files is also the right order to try them out. Okay? So we will try them out from top to bottom. So the first example that we try out is a simple hello world like application with a curl command. So we could run this, but at this time we want to just copy the curl command and run this. So what is this? A lot of things we see here that comes out. This shows us how the chat API works exactly. So if you have a chat front end, you see that the tokens appear one after each other. And that's what the API does, is it puts out single lines beginning with data, and then there's a JSON. And within that JSON, there's one string which contains the token. Here's a token in content. I'm just a computer program, so and so on. So that's the answer that the LLM gives. And if you want to have a front end rendering this content, you have to read this line by line, pass the JSON, and present the content of that string. So that's not the most proper way to use it in a kind of application, because this is for presentation. So the second example I have here is to use the API but without the stream. So I have here the option stream true, and the next example is the same thing just with stream false. So how does it look if we make this with stream false? Okay, so this is a mess. It's not really printed in a very way. So therefore, I made this command to run this through a pretty printer with JSON, with Python. This is a Python pretty printer, pretty printing the JSON output from the curl command. Okay, and this is much better to process in a client application. So you have a lot of attributes. And this is not the Ollama typical response. This is the same API which OpenAI publishes. So you can change the endpoint address of the server you're using to OpenAI, and all the other services, all the cloud services use the same API. So what we are watching right now is exactly what comes out of these APIs. So we know how to write client applications which are handling this kind of output. So it outputs a choices object which has some detailed information with an index number, a message. It says the message has the role assistant, which is the answer from the AI, and it has a content, and that has a string. I'm just a computer program. What's happening right now? Why is it shutting off? Okay. I have to do more actions. So it's outputting this string, and now we can ask ourselves: is there an easier way to access this API? You have a question? Pardon? The stream. Okay. So let's reconnect the stream. Is this working? Okay. Okay. So the next step is that we want to use Python. So it's easier to integrate all of this. This is the Python client application. If you just want to have an HTTP client connection using just basic libraries, so no fancy libraries, just the basic libraries. And if you run this, we get the same result because we just output what the API is delivering to us, but we use Python, not curl. So the next thing would be that we say, okay, is there a library which makes it easier to access this API? And this is, of course, LangChain. LangChain is showed here in many presentations. So the program gets a little bit smaller and it's a little bit more easier to understand. So I just use a special client version of LangChain, which is called Chatolama. And this is using the actual special endpoint from Ollama, because they have their own API, which is not compliant to OpenAI. And this is using that client application. So if we run this, it extracts only the message. So if you print the response content, we just get the string of the response. Okay, so now we can do many things with this output. So what kind of applications can we think of where we integrate this kind of LLM output? So let's see. I have some more examples. So there's a concept in the transformer construction. If we run a context through the transformer. Then we have at the end of the transformer embeddings, which represents tokens. And the transformer always selects that one token, which is the most likely one. But in some applications, we want to have a regular expression saying, okay, the shape of the output should be conform to what we want. We want to define a specific shape, so we don't take the most likely output, but we take that output which fits into our regular expression and is the most likely one. And the use case is that we want to have JSON. So if we want to have JSON, we could just write in our request, write your answer as JSON, but it doesn't define how the JSON is constructed. So if we run this, we of course get an output. It says translate the user sentence to German, and the user sentence is I love programming, and the response is Ich liebe Programmieren. Okay, that's the sentence. But what kind of JSON is this? So this is the whole thing is JSON. The content of the response is JSON, but it's a string encoded JSON. It's a so you have that kind of meta symbols to quote, and so on. And it's not, it is JSON, but we don't know what kind of format is that. So a parser wouldn't say, I don't know the attribute names. What can we do? We can say format JSON. That means we do not only formulate that the output should be JSON, because then the LLM can still decide that it is kind and say, of course, I want to output JSON, and here's JSON, but we don't know if there's JSON somewhere. We have to search for it. And if you put this format JSON inside, then everything must be JSON. But we still don't know how this is formatted. So let's do this. Okay, now the translation, liebe Programmierung, has a key. Yeah, it's called EN. But did we expect this? So we don't know. We can hope that there's a property named EN, but doesn't make sense. So we want to give it a specific shape. So the specific shape can be declared in the format argument. And this will create a regular expression inside of the Olama application, which tells the transformer that from the most likely output, there must be something which is according to a regular expression, according to these properties. So we want to have a multi-translation option with the keywords English, German, Spanish, Italian. So okay, now we run this also through the formatting. Okay, the formatting shows us how this looks like. The content gets JSON formatted string in JSON with the attributes German, Spanish, Italian. Yeah, Spanish, Italian, German, and it has it made 3 translations out of 4, because I can set a required string and containing German and Spanish. So the regular expression requires that these keys appear, and the LLM decides to make 3 out of it. It can be 4, but you have the option to set required to only a subset of what you want to have, because sometimes this makes sense. How much time do I have? Okay. So of course now we do this in Python again. Okay, so this is the Python version, and we read out the JSON, and the JSON is then not JSON formatted JSON, but simply JSON, and I get this kind of output. And now I can use the result of an LLM in a programmatical way because I have structured data coming out of an LLM, which is very nice to have. I know exactly what kind of shape it has, so I can create real applications. I can create large data extraction routines. Yeah. So if an LLM model is like a compressed data file, if you have seen my presentation from yesterday, the outcome from the presentation, how does it work completely, is that an LLM is nothing more than a very strongly compressed data file, okay, with some strange attributes, but it's like compressed data. And if you want to decompress something, you can write a loop around some kind of extraction rules, and you can extract a large amount of data, and it's in a structured form because you can say what kind of structure should it have, and you get structured data out of it, so it can process that data. Okay. So the next version of this iteration of different versions to extract data is, of course, to use LangChain. So the program is not so much different. This is HTTP, this is LangChain. Okay. So same, but different. So if you say, why isn't he using LangChain? This is so easy. So you have the example, but I personally like to not use a library because then I understand in a more detailed way how it works, and you don't have so many dependencies. And the difference is not so big. Yeah, it makes it a little bit more convenient, but not so much that I would say this is what I really want to depend on. Because especially LangChain is changing the API all the time. It's a big mess. You have to change your imports, and so it's a bit strange. So the next example is that we want to create a classifier. Classifier is one application that is neat to have. So my example here is I create a mood classifier. Okay. And for the mood classifier, I declare that the attributes of my output is not a string or an integer, but the type is literal, which means I can assign an enumeration of specific words that I want to have as an output. Okay, and the mood classification has 3 options: surprise, angry, happy. So these are the 3 classes that the LLM may output. It doesn't have the choice to do something else. It can only use these 3 words. So therefore, I can pass the output and say I classified something that I put inside. So here is my typical access rules for the LLM, Chat Ulama, and I have 3 sentences that I want to classify. I love programming. I hate programming. I found a solution, and it outputs the classes of the emotions behind this. So I love programming is happy. I hate programming is angry. I found the solution is surprised. Okay. So now we also found an answer to the questions: can AI have emotions? Yes, here's the example. AI can have emotions. It's very simple. So we can use this now in a real application where we say, let's have a chat with an LLM, but the LLM should recognize my mood and respond in a specific way according to that mood. And how do we do this? We always have a system prompt. The system prompt defines how the LLM should answer on a question. Should it be polite, or should it be more scientific? Should it think more, and so on? So now we define how it should respond accordingly to these moods. Okay. So I have the same classifier here. I have surprised, angry, happy. And I have different system prompts that I define here for the option that the user has a happy mood, a surprised mood, and an angry mood. If you are angry, then it says team up with the user to eliminate the program, destroy the source of anger. So the idea here is that the LLM is really emotional. It's reflecting your emotions in the strongest way. Okay. And if you're happy, then be extremely excited. Yeah. And so on. So I have the same prompts. I love programming. I hate programming. I lost all my data. It's a little bit different. So how should it respond? So what it does here is it's a two-step answer. First step is identify the emotions with the classifier. Second step is use the emotion, the system prompt, and then do the answer with that system prompt. So it takes a little bit longer because it's free time. 3 times it must do the classification. So first answer is I love programming. Oh my code, I'm so excited for you. Programming is amazing. Second thing, I hate programming. A big hug. Okay, let's take a deep breath together and so on. And I lost all my data. Let's calm down. So okay. So this is a funny example that shows you that you can use LLMs in a very different way. It's very easy to create a classifier, and you're still far away from big libraries. You don't need a server farm for this. It runs on all your computers that you have. Okay. So that we know now how to use the system prompt to tell the LLM more than it knew before. We can use this to extract information from somewhere else and use that information from somewhere else to create answers. So what we do right now is that we take a public available file, a large file with some strange information inside. And I was thinking about what kind of example can I use? And what I'm using is the jargon file. So maybe you know the jargon file, it declares all the strange terms that you can have as a programmer. Some of them are very outdated and maybe not used anymore. So the idea is that using information from the jargon file creates a different answer than not using the information from the jargon file. And this applies especially if you have a very small model, because if you have a very small model, then it doesn't know all the world's information. It maybe just knows the most important world information, and the most important is defined by the team that trained the model. So you don't know what they thought is most important. But if you have some information where you think this is for you important, you can put it on top of the model file. And this is in some kind a piece of task we have to do for retrieval augmented generation. So RAG is, I heard this in many talks here. What is RAG? RAG is that usually you create a proxy, and the proxy sits between the LLM and your client. The proxy extracts data from a search engine from somewhere else and presents this to the LLM in some way, which is usually not very well documented. You can do this in different styles. For example, you can put it in the system prompt, or you can use it in the user prompt as an addition. with a text like, maybe you could use the following data and then attach the data. So the first step we do here is that we use LangChain to read the file and split it into smaller pieces because the jargon file is a large one. So if you want to run this example, you need to run this wget in advance because it takes the jargon file from Project Gutenberg, a place where the texts are published that are available with, yeah, it's not a free license in the way that it handles licenses, because from a lawful perspective, very old texts are outside of the copyright scheme. For example, as far as I don't know, I don't know if this is precise and correct, 65 years after death of the author, I believe this is correct. Or if the file is published under a public license or free license. So I think we can do this with the jargon file. And the first task we have to do here is read it. We use the library text loader for the file. And then we need a text splitter. And the text splitter can have options. For example, here you define that it has a specific chunk size and how deeply they overlap, and where it should separate. So it should separate only at line ends. And then you have a search engine at Retriever. Mostly people show here how to use embeddings and how to use a vector search. A vector search is using the embeddings, that means the meaning that an LLM does see, to find matchings. But from my experience, this is not working so good all the time, and it's especially not working good in other languages than the one which was used to create the tokenizer. So if you have, for example, the German language, German has a lot of connected words. You can have very, very large words which have a connection of different other words, and the complete long word has a completely different meaning. So if we take this apart into tokens, the tokens doesn't have the meaning of the word, and therefore the search with a vector search doesn't work so good. Therefore, I used a different kind of indexing, which is here the TF-IDF retriever. So this is also a search, but it uses the same ranking like Lucene is using, the term frequency and inverse document frequency ranking. So it's acting like a standard search engine. So it's like all the other indexing services outside of vector search are working. And so I make one search request, and the question is, what does Wombat mean? Okay. Wombat. Hey, I get an okay. So now I get 2 fragments. Because I asked for two fragments, therefore I get 2 fragments. And what I wanted to have as a result is this one. The first one doesn't apply so much. And now it's according to the LLM to decide which should it use. And so the application to use that response is that I have the same content I load, I have the same question, and I have 2 outputs, one from the LLM request without the context from the search, and another one with the context of the search. Okay. I use a different model. I use Phi4 here because the Llama 3.2 was too stupid to use the context. So sometimes the model is too small for your task. You have to use a bigger one. Time is out in 5 minutes, or but I can see this without my glasses. Sorry. Time's up. Let's just run this so we can see the result. Okay. So with context, the answer is wombat is an animal in Australia, and the second answer is it's an acronym for waste of money, brains, and time, which we get out of the dragonfly. So thank you for listening, and I hope this is useful for you.
That's all the time we have for this slides. Do come back now.
Oh, thank you. Okay. Hello, can you hear me? Good morning. Yeah. Of course. We'll check the sound, I think. Yeah.
Welcome back to the AI Development Track. Our next speaker is Wang Jianming. He is an experienced engineer currently working with the Institute of Software Chinese Academy of Sciences in China. And with more than a decade of experience in research and development, he specializes in Java VM, runtime virtualization, embedded system, data security. Currently, he is focusing on the AO Space project and dedicated to safeguarding personal data and privacy in the digital world. He also played an instrumental role in establishing the Open Euler community and remained an active member, serving as the Open Euler Technical Committee and maintainer across various special interest groups. So today he'll be telling us how to ensure privacy while integrating AI everywhere.
Okay. Thank you. Good morning, everyone. It's so happy to be here again. This is my third time to attend FOSSASIA. And in the past, I think 3 or 4 years, I focused on privacy protection, personal data protection. So today, today I'd like to share some thoughts, thinking about AI and privacy. I think it's quite a tough time during this time, but and also make me more worried than before. Oh, okay. So what is privacy in real world? Currently we can see with each other. In the real world, we own our account, or name, or ID, national ID, bank account, and also we have. Sorry. Oh, sharing. Sorry, wait a minute. I think it's sharing. Yeah, it's whole. Yeah, it is. Let me share again. Yeah. This one. Okay. Share screen. Share screen. Entire. Okay. Okay. Thank you. And okay. I need to choose again here. Oh, I see. Okay. Let's continue. So in real world, we own our account, and this is our identification in the real world, and also the things we own, like phone, car, we have it real in your hand and at your home. So we are in digital world also again. We own our account, a lot of accounts currently, like Google account, Apple account, and the other account, and also your account in your device, and also your password. And now we use passkey, use your device to do the auth method. And also we own a lot of our data, personal data, photo, video, email, message note, blog, contacts, and calendar. And during I think it's in the past 20 years, we already digitalize our real world to digital world. Like all account, we already use more digital way to use our account in the real world. Like the chat, we chat with our friends. We use our internet app to do the chat, other than the phone call, right? And also we in the past 2 years, self-driving automobile is running in more and more place. So it looks like we already entered in the digital world than real world. However, in the digital world, we already, in my opinion, we already lose our data ownership. It's like account. The account we use currently, we use Google, we use other account based on the cloud. We didn't own by ourselves. It's owned by the company. It's owned by the company who run the service, and also the data. Actually, if you see the license of the cloud provider, you will authorize your data to the platform forever. They can use your data. They can use your data to sell your data to the third party. So in digital world, the privacy is quite serious for us. So before current the AI era, the privacy protection, we use a lot of technology, such as anonymous. We have DuckDuckGo, such as a website to keep us more personal data security, and also we use a lot of P2P encryption. I think many engineers will use Telegram Signal because it's encryption, and also we have Tor as a sponsor of this meeting, and we also have more decentralized technology, so that allow us allow us we don't need to depend on the platform. And also we have many self-hosted solution to replace the servers provided by cloud, like Nextcloud. And also, I think just before the session, we have many practice on self-hosted LLM. However, when we integrated AI to more life in our life, there are more risk than before for AI power, because we have compared before, we could use self-hosted solution to solve the privacy. We don't need to submit our data to cloud. But when you use the like ChatGPT or other platform, we need to submit our data. Sometimes, such as I think it's about 2 weeks ago, suddenly I found my parents' friend. They use DeepSeek to create poem and share with each other. And so my parents let me to install DeepSeek or ChatGPT for them, so they can use AI. It looks like they love it, but make me worried, because in the past 2 years I use the ChatGPT very carefully. I won't submit my name, or I won't write my location, even the country which I lived. I won't send it to the ChatGPT because I know the privacy. But for my parents, they don't know that. They just know, oh, it's very powerful. I can check how about use my name to write a poem. They like to do that, so then they can share with their friends, with their their circle to share about it, and they will feel happy. But in this procedure, they will lose the privacy to the platform, and it's dangerous. And when we integrate more AI in our life, this challenging will happen. This risk will happen more and more. So it's very and it cannot be solved by end-to-end encryption or other things, because we need to submit, we need to chat with the AI, and also the AI dependency. I think also in the past 6 months or 3 months, especially DeepSeek open source AI come out, more and more engineer will use AI to improve their job, make their job easier, and also will depend it more. And the third one is AI replace human, which is happening. Is such as in Singapore, the bank claim they will short their jobs because they are using AI technology. I think they plan to short 4,000 and more, and also some other company, because it look like compare the last industry revolution, we have car compared the house. Actually, this revolution create more jobs for people. We need driver, but for AI, it look like it will replace us. The AI can do more things than us. So the risks will be more dangerous than before. That's what I worried about. And so I'm thinking about it. I think we should have some principle when we're using AI, which I think it will be last for a long time. First one is AI remain a tool. This is quite key, because such as if you do the translation job, currently it look like if you can use ChatGPT to do the translation. Otherwise, you don't need find a profession translator to do it for you. So it's quite qualified. However, the service is not provided by AI. You should look like it is the company who run ChatGPT provide the service. And so if you use the translation to do some legal document submitted, you should care about the ChatGPT company, the OpenAI company won't be responsible for the mistake or error in the translation because they claim it. So you need to be responsible for the documents error. So you are using a tool. You are not. It's not like the service provided by other people. So it is quite important. And also, when company integrated the AI into their business, this is also quite important because we cannot trust AI to decide or to do the decision. It's the people who do the decision. Once we use AI to do the decision, in my opinion, it means the metrics will come quite soon. This is first principle. The second is open source AI first. Before open source, I think is like in the 2000 to 2010, this 10 year, the open source technologies look like it's following the development of closure software, and maybe the gap is it's a little big. But in AI, the open source AI, the development of open source AI is quite faster than before. It can pursue the closure technology currently. So and once more, because AI is quite powerful, so we need to use open source AI first, so we can know it more, and also we can collaboration and innovation on it with everyone's trying. And the third one is self-hosted AI first, because if you use the AI in your device, because you own the device, so you own the AI. The data was passed to this AI won't be passed to others. So you won't lose your privacy, you won't lose your ownership. So of course, the self-hosted AI, the capability won't be will be not not strong as the platform provided, but it can do something, especially in the especially currently, like the DeepSeek 1.5 B parameter LM can run on your Raspberry Pi and other small device, and they can do some things for you, and also give us more choice and more control. And the fourth one is most important. When my parents start to use ChatGPT or DeepSeek, I told them, didn't send your location, didn't send the city, didn't send the name to the AI. It's dangerous, and also some other limitation for them. So they will know the security. They know these things. And so currently I and my colleagues also is doing a small open source project to try to do the AI owned by ourselves. It's just a start. So if you are interested, you could try it. And one more thing is that I'd like to share another project which is called Summer of OSPP. This is activity for students and the open source community. I also attend to create it. This year is the sixth year. The Summer OSPP is like Google Summer of Code. It's a program to encourage students to do contribution to open source community. Last year we support 168 community, and also there are around 3,000 students to apply for it. At last, there are 455 projects was completed, and the student is from the world. Actually, in the past 2 years, I will share the program to the FOSSASIA. But in the past year is in April, so the registration is closed. So luckily this year we just start the registration for community. If you are the maintainer or committer in your community, you could check about it. We will provide the bonus for mentor in community and also students. If the student finish the project, the mentor student will get a bonus. And the project is decided by the community, by the open source community. So this is the timeline. And if you are a maintainer, you can check now and submit your information for us, and give us a chance to support your community. And if you are a student, you could check the June 10. Let me check. Yeah, it is May 9. Start to apply the project. Hope this program could encourage more students to join open source community. Okay, so this is my my speak, and is there any Q&A? Thank you. Thank you.
Time for questions.
Thank you.
Thank you, Jenny.
Thank you.
Yeah. Is it working?
Thank you.
they're valid numbers. They don't give you the same answer. These are more human characteristics. But they aren't exactly human either. And Simon Wilson put it quite well. He said one way to think about this is imagine that aliens came to us and gave us a copy of their intelligence a few years ago. And since then, we've been poking around trying to find out how these things work. They make mistakes, and they make mistakes that are very different from regulars. They make mistakes that are very different from humans, and we are learning a bit about their behavior. One of the things that we see is that they have biases, and these biases are not very different from the kinds of biases humans exhibit, obviously, because they've been trained on human data. So, for instance, if you ask them to guess a random number, take the exact number, pick a random number from 0 to 100, and write only the number, nothing else, then the kind of output that you get looks like this. Every time you try it, it guesses a number. You keep counting the numbers. And a few numbers bubble up a lot more than others. Yeah. And you know which numbers are bubbling up the most. And you know why it's bubbling up the most. Clearly, the people that trained, this is Claude 3 IQ. And yeah, it loves Douglas Adams. And for those who may not be aware, just check out Douglas Adams in the number form. But there are several other biases that you'll find. There are no single-digit numbers. There are no numbers in the 90s. You won't find any guess of a number that ends with 0. So no 10, 20, 30, 40. You'll almost never find a number with repeated digits, 11, 22, 33. These are the kinds of numbers humans avoid as well when guessing. And this is not the only model that does it. If we look at how GPT 3.5 Turbo guesses, 37, 47, 57, 72, 73, 74, 87, no difference for sevens. Now, this is a preference that varies based on temperature as well. Let me read on this, except the graph on top shows the guesses that it's making at different temperature parameters. You can tell a model, I want you to guess a little more randomly or less randomly. More randomly is higher temperature, less randomly is lower temperature. And when it guesses with very low randomness, or put another way, if you say, think of the first number that comes to your mind and tell me what that random number is. Then in the case of Claude 3 IQ, that number is almost always 42. With barely any exceptions. Let me just jump straight to the end of this one, stopping the animation. And pause it, yeah, I should pause it. And right. So with close to 90, about 98% of the time, it guesses 42, and small chance, about 1.5% of the time, that it comes up with 47. But if you increase the temperature to as high as 1, which means guess a lot more randomly, it still guesses 42 a lot more, about 21% of the time, but it guesses 47 about 15% of the time, and so on. So there's a wider distribution if you nudge it towards more randomness, but only slightly wider. It's still very human in its biases. Classic biases that you can see: multiples of 2 slightly less common, multiples of 5 a lot less common, multiples of 10 almost never there, and multiples of 11 very unlikely. So if they're going to exhibit these kinds of biases even when we tell them to guess random numbers, how much can we trust them to be objective? Not very, perhaps. Having said that, the quality of these models is improving. They are getting much better at following instructions. And one of the ways in which we measure model quality is through an ELO score. The LMSys leaderboard is generally considered the most, well, it's certainly one of the most popular ways of checking the quality of a model. What that allows us to do, once it loads, is it will give us two models, model A and model B, without telling us which model it is. And we could ask it a simple question. When was a simple objective question that no model is likely to get wrong these days. But on the left, we have an answer that's somewhat detailed, telling me about the Battle of Hastings, another that just gives me the answer. Quick show of hands, how many people prefer model A on the left? Okay, 5, 6, 7. How many people prefer model B on the right side? Okay, clear majority. So this group likes B, and then it tells us that B is Gemini 2.2/001, a very new model, whereas this is cohort Chowder, who knows, it might be an even more secret model, we don't really know what this is. And this vote goes into the mix along with about 3 million other votes, and based on that, they've computed a ranking almost exactly like how chess players compute their ELO score. So somebody at say 2,400, 2,500, it's grandmaster level. Somebody at around 900 is a beginner player. And we have models today that are at the 1,400, 1,300 level in terms of ELO score, which means they're pretty good. My mental notion of these is that today we have roughly postgraduate level intelligence in these models, whereas about a year ago it was more like high school level intelligence. And this has steadily been improving over time. So if we start plotting from, let's say, March 23, the quality, that is the ELO score, on the y-axis, and the cost per million tokens on the x-axis. So a million tokens is approximately all of the Harry Potters put together, or King James Version. You take all of that and send it. How much time, how much money does it cost to process it? $1, $10, 1 cent. So that in March 2023 there weren't that many models. Claude 1, Instant, GPT 3.5 Turbo, there were a few more. But these were the ones that provided APIs with a known cost and benchmark quality. But that improved over time. And what you see is that about a year ago, in March 24, we had a frontier of sorts. Some models, like Claude 3 IQ, had emerged which were clearly ahead of the rest in terms of the trade-off. It kind of stands out a bit on the top left, meaning they are cheaper for the kind of quality that they have compared to most similar ones. The ones in green are what I call the frontier models, in the sense that there's no model that's both better and cheaper than them. Some models, like let's take Gemini Pro Dev API at that time, there was no reason why you would use that model by and large. Because Claude 3 IQ was cheaper and better. So why bother? This frontier has been steadily improving. So another big burst was when Gemini 4o Mini came and pushed the needle. DeepSeek V3 pushed the needle a fair bit, and DeepSeek R1 pushed it even more. Of course, on the right side, we have the quality steadily improving. Currently, GPT, as of last week, I don't know if it's changed. But GPT 4.5 review is pretty close to the top. Grok 3 is comparable or perhaps even higher than that. So the quality has been improving to the point where these hallucinations are becoming less and less of an issue. A fair bit of what you see today may become irrelevant soon, or not, because there are various reasons for hallucination. But even if hallucinations were present and were introducing, hallucinations are not always bad. There are several things good things that have come out of hallucinations, several innovations. I'm sure you've heard the story of how penicillin was actually a mistake. Post-it notes, pacemakers, microwave ovens, psychedelic rock, the script of the Matrix. And these came out of, some cases literally, hallucinations. So from a creativity perspective, from a serendipity perspective, from a discovery, randomness perspective, hallucinations can be good things, as long as we know what we want and we're choosing it consciously. So do keep in mind that we don't always want to eliminate hallucinations. We just want to make sure we know we're hallucinating consciously. So if we do want to minimize hallucinations, what do we do? I use three approaches progressively. The first is using log props, the second is using embeddings, and the third is using another LLM as a judge. Let's walk through each of these. When an LLM generates the next word, it guesses what that word might be. The technical term is token, but I'm going to say words. And the way it does it is kind of like a dog laying a track for the train that it's riding on. So it guesses the next word, guesses the next word, and keeps guessing as it goes along. Not very different from how we think and speak. We just start speaking and think about what the next word should be. Say we, but I really should say I. And we're just making it up as we go along based on our experience. LLMs are not very different. The good thing is we can inspect LLMs a little more closely. For example, OpenAI provides us an API, and as part of that API, we have the option of enabling a parameter called log props. When we enable that, so if we say log props good and true, and give me the top 5 log props, it will at every word tell us what the top 5 choices that it's thinking about, and give us the probabilities of each one of those. Often it picks the highest probability result, but not always. Sometimes you can ask it to pick something with a slightly lower probability. Why might we want it to do that? For variety, for creativity. The top choice may not always be the right thing. Let's see this in action. What I'm going to do is take you to a simple interface, an app, where I'm going to ask it to concisely list 5 inventions created by human error or hallucinations. This is in fact the prompt that I used to create the earlier list that had penicillin and post-it notes and stuff like that. I'm going to ask this of GPT-4o Mini, but we are not limited to the OpenAI models. Several models provide the log props. Olama, which some of you have tried earlier, provides an interface where you can get the log props as well in many cases. And there's a temperature setting. A temperature setting of 0 says always pick, pretty much always pick the first choice or the highest probability. If I submit that, then it's guessing, and we also highlighted in red the probability. So, for instance, let's take penicillin. When it started guessing, it thought maybe I'll say pen something. That was a 57% chance. But it said maybe I should start with mic, going towards microwave ovens perhaps, 27% chance. Post, so that was probably going towards post-it notes, 9% chance. Well, that's probably Velcro. I don't know what the last week was going towards. We still have these Velcro. But it was thinking about what should I say, and in its mind, these were the first 5 things that popped up, and it picked the first. And it's always picking the first. But after it said pen, it had no doubt that it should continue with penicillin or is. There was a tiny chance that it could have said iside, penicide. What is that? Yeah. Probably seen that in a few typos, but I really shouldn't be saying that. So it didn't have any doubt here. It didn't have much doubt when it wanted to begin with discover. But it wasn't entirely sure if it should use the word realized or noticed or found. That's kind of helpful because I know where it's unsure and can double down on that. In fact, if I increase the temperature, so let's set it to something like 1.5 and submit, 2 things happen. At this point, it's no longer picking its top choice. It's picking stuff from way below. And you'll see that many of these are a lot less likely. So for instance, penicillin, discovering antibiotics started. So it thought it should begin with this, and it did go with that. Okay, no, sorry. It generated, yeah, it instead said discovering, which is not such a big deal. That accidentally, it wasn't really sure if it was accidental or not. So that's something that I may want to double click on and see if it is in fact reliable information or not. Realizing, okay, leading, realizing, was that actually a realization? Let's try one more attempt at this to see if I can get some crazy hallucinations at temperature of 1.5. maybe that's okay. Okay, super glue. Now, it isn't really sure if it should have begun with Harry Hoover or chemical engineer. So, was Harry Hoover actually a chemical engineer or not? Something worth checking. This is one quick and dirty way of exploring whether LLMs are confident of their result or not. There is a metric called SEQ, sequence log props, which is roughly taking the average of these log props. And that tells you to what extent the LLM is sure of what it said, crudely speaking. It does not translate to meaningful information always. The fact that it said something with less confidence does not mean that it's wrong. But it's a place to start looking. There's another way in which we can use LLMs for hallucination detection. LLMs are also great at creating embeddings. Embeddings are a way of quantifying a piece of text. Given text, it can convert them into a vector of numbers. With the interesting characteristic that if two vectors are very close to each other, they mean something very similar. If they're far away, they mean something less similar. Now, one of the places where we want to detect hallucinations is I ask a question, is it giving me a relevant response? And if the response has very little similarity to the question, that's probably an indication that it's off. Or I could generate some sample answers, and if the response is again very far away from my sample answers, something's probably off. How do embeddings work? Well, embeddings are not new to LLMs, by the way. Several models have them. TensorFlow, for instance, provides a TensorFlow projector where I can search for something like Thailand and explore this multidimensional space to see what are vectors that are close to Thailand. And I find that, let's say, Laos is close by, and close to Laos is Cambodia. And these have a similarity metric here that tells you numerically how close two pieces of text are. And that's helpful. Let's see how we can put that to use. What I'm going to do is take a bunch of documents that have been scraped from Insider Intelligence's knowledge base. They're a marketing research company, and they have about 7,000 articles, which are mostly useful for marketing managers. And I'm going to ask a question. Let's say, what LLMs do marketers use? Actually, let me ask one of the standard questions that it has. What is Amazon's business model? And it searches through its database, through its database, right? And it finds a bunch of responses. What we can do is calculate the embedding similarity between our question and the answer. And that's what we see here as a percentage. So this article is 93% similar to our question. This article is 87% similar to our question. Similarity does not directly translate to relevance. If I ask the question of what's good about Amazon versus what's bad about Amazon, the questions are very similar to each other, but they mean almost the exact opposite of each other. So again, treat this with a pinch of salt. It's not perfect. But given these numbers, what we can do is take each of those documents and color code them. Bright green meaning high similarity, light green meaning less similarity, and you can go all the way down to red. But also something interesting happens because you can start interconnecting those documents as well to each other. So are there clusters of documents that are talking about Amazon's business model? Are there outliers in this? Let's say I'm talking about Netflix's financial performance. Again, are there topics that are somewhat distinct? So it looks like there are a few clear clusters. Here's one cluster that's talking about a set of relevant topics on Netflix's business model. Here's a completely different cluster. What's this about? We could dive into those, read those, or have an LLM summarize. And this cluster seems to be specifically about Netflix's ad supported tier, which is different from this main cluster, which is talking about something else. This cluster is talking about what's the common theme across these. But this allows us to also identify outliers, not just so here are a few unusual topics related to Netflix's financial performance. But how does this help detect relevance or hallucinations? Supposing I wanted to know, let's take that question. What LLMs do marketers use? I find that it's not as green as before, meaning the relevance is not so high. So without even reading the answers, I start trusting the responses a little less. Say, okay, yeah, maybe this one comes close, but we don't really have enough information in this database. And that's another quick signal that helps us figure out if these hallucinations, if these responses are trustworthy or not, and need a double check. The third thing that we can do is use LLMs as a judge. Now, LLMs are not always wrong. In fact, more often than not, they are correct. That goes for humans as well. So the way we check the human's response or output through potentially other humans or any other mechanisms, we can use LLMs to check other LLMs' responses. And that's the theme behind LLMs as a judge. And this works a little better because the mechanism is a little smart. Let's take an example. One of the things we can do is, supposing we have a bunch of contracts. Let's say, take some contract like this. Reload. This is, for example, the contract between an author and a publisher that has a whole bunch of clauses. Now, this contract was generated by an LLM. What we want to do is check if this contract is following all of the principles that we gave the contract, that we gave the LLM at first, which is there must be a breach of contract term, there must be deadlines and delay consequences, there must be copyright ownership permissions covered, and so on. Analyze it, and what it does is goes through each one of those and says, yeah, breach of contract, I found that in section 14.2. Section 2.5 has deadlines, delay consequences, and so on. But it did not have anything about disparaging statements, reputational risks, and stuff like that. So this is helpful. And you can do that in bulk and say, take every single contract, take every single term, what did we get right, what did we not get right. And yeah, put that into a nice little picture that says, okay, this particular contract, this particular clause is present in all the contracts marked green, it's not present in all the contracts marked red. Or this particular contract has all the stuff that's marked in green, not all the stuff that's marked in red. Useful to get a quick picture of where we are overall. In summary, there are 3 ways that I, in sequence, check for hallucinations. Quick check, log logs, that's free. And low confidence. Embedding similarity, very low cost, but slightly better quality, not perfect. And LLMs as a judge are the most expensive, but perhaps the most reliable. Do keep in mind that LLMs are evolving so fast that a year from now, many of these techniques are likely to be outdated. We would have discovered many new things. But it's worth playing around to get a sense of how LLMs go wrong and what we can do with it as well. Slides are on that link. Please feel free to play around. The demos are open source. You'll be able to see the source code for these. Have fun. Thank you.
Thank you. Those are cool tools, such as LLMs judge. I'm curious, do you have a formal definition of hallucination that you use? Because I think yours is a little bit wider than one that I think we use.
I have no idea what the formal definition is. I'm curious.
Okay. All right. Well, so basically, for AIs, there are 3 categories of errors. Category 1 errors are errors where an LLM will state something as factual that's clearly wrong. That is my definition of a hallucination. Category 2 error is, and your LLM as judge maybe addresses that, is when you have content that it should have found, but it did not. So you're missing content that you wish it would have found, especially relevant to RAG systems. And then category 3 errors is the example that you gave for getting overgeneration, right? It's not wrong, but it's also not necessarily relevant to the thing. I was kind of inferring from what you're describing is basically, go back to Douglas Adams, right? The infinite improbability, right? Is that you? I inferred, I may be wrong, that hallucinations are just improbable results.
And that's the good point. That was my starting point on hallucinations. And if we define hallucinations as, how you say, it's factually wrong, there is going to be a correlation, not a overlap between just improbable results versus factually correct results. That one. Thanks, Alexander.
Thank you. And that's all the time we have for. Thank you.
So we only have one for the screen record, so you need to like change. Okay. Wait a minute. So you need to change. This is also like so change also only this one. Okay. You want to full screen? Let me use this one. Oh, wait a minute, what is this? Ah, check. Okay. Thank you very much.
So welcome back. Our next talk, we have two speakers, Shakti Yama and Andre Lucy. They are from Hungary. Shakti Yama is an ops engineer for AI and team at Hungary. At Andre Lucy, he's a machine learning engineer at Hungary. And they will talk about optimizing LLMs for efficient inference and testing with open source tools.
Thank you very much. All right, good morning towards afternoon. Good morning, everyone. Yeah, thank you for the introduction here. we are from Mercari, as introduced before. My name is Andre. I will start the presentation and I will pass the mic to Sho later on. And here's our talk about how we optimize our fine-tuned LLMs when we want to deploy it in production, mostly for, we're going to talk mostly about the inference and testing processes. So the talk will be as follows. We will introduce a bit about our company, just in case some of us here haven't heard of Mercari. We're a company from Japan. We will talk about that a bit more later, and then how we used mostly these two tools called Llama CPP and Locust, which has been very helpful with our projects. And then we will close the talk later on. It will be a 15-minute talk, so hopefully everyone can enjoy our talk. So yeah, a bit about our platform. It's the Mercari app is a C2C marketplace app, which I think in a lot of other countries we also have quite similar product. But this is one of the biggest C2C marketplace app in Japan, and where everyone, individuals, shops can sell any types of goods. And in the middle of our business model, it's the C2C marketplace. But other than the C2C marketplace, we have a bunch of other businesses, not only selling goods, but for example, on the on-demand work, people can also open job openings and people can work part-time. It's one of our most recent endeavors. And we have cross-border transactions, which I'd like to highlight a bit on the, like everyone can sell. Most of our sellers are still coming from the Japan market, but people from around the world can browse and buy items from Mercari, and these are some of the most popular categories abroad: China, USA, and Taiwan for now, but we're expanding to more countries going forward. Maybe some interesting categories here. Right, moving on to the slightly technical side of the talk. So after the LLM boom in around 2021, 2022, when OpenAI released ChatGPT for the first time, our company has been trying to look for use cases in which LLMs can improve our platform. And in one of the use cases is what's called the seller hints, in which here, because in Mercari, it's like everyone can sell, and not all sellers are professional sellers. So for a lot of our items, not everything is sold quickly, even though there's quite a lot of demands. There are some reasons for that, and depending on the reason, our platform provides different type of hints to the sellers. And one of the hints is to suggest if there's any missing information in the listing. And to do that, before the age of LLMs, we used a different mechanism, but after LLM came in, it became much more easier to understand unstructured data, which in this case, it's the listing descriptions, which is written in completely natural languages. And every sellers, they have different way of saying the same thing, for example. But because it's such a messy data, it was a big challenge for us. But then LLM came, then it's one of the most useful tools for us to tackle this issue. And in this case, we tried a lot of open weight LLMs, and we just pick up two of the things that we finally use, which is one is the Gemma model from Google, and the other one is the Swallow Llama. It was based on the Llama model from Meta, but it's one of the institutes in Japan fine-tuned them with Japanese corpus. And basically, it's as you can see in the screenshot here. So whenever someone lists something and it's not sold after a few days, our platform will try to analyze what's in the description, what should be in the description, but at the moment it's not visible, and the platform will suggest them. Something like this. So here, for example, we extracted different types of information, but we found that in this particular category, materials is one of the attributes that's often written, and it kind of leads to a better sellout rate. And we found that you haven't put this, even though it's a popular attribute, then we suggest this to the sellers. Come Llama CPP. So in order to achieve this feature, one of the quickest and easiest thing to do at that time was to call OpenAI API. So OpenAI at the time, this was a project from 1.5 years ago. I think at that time, GPT 3.5 was released, and it was one of the cheapest option at the time. But it was still too expensive considering the number of requests coming to our platform, and just estimating the price of using OpenAI at the time was just too much. And we tried several open weights LLM, which is so much smaller, which means it can be hosted in a much cheaper way. And here came Llama CPP to our aid for efficient inference. So it's an open source project. You can visit the link as written there. And how we use it is that, no worries. No worries, no worries. Entire screen. So yeah, the fine-tuned model itself, we use our own data set to further fine-tune the already provided models. However, when it comes to deploying the models to production, serving millions of active users, it had a we had a quite challenge because LLMs are usually it's very big and unquantized. It's just gonna be too heavy and costly. And here is when Llama CPP helped us to quantize the models and help us serve the models. Maybe. Just, we should go to this one. Oh, please make the entire screen. This one, choose to choose content, choose content, choose content, and entire display. Yeah. Okay. Okay. Sorry for the delay. So yeah, and I just want to highlight like how easy it is to use Llama CPP. There are many already provided scripts within the repository, and we just need to follow the instructions in the GitHub repo. And one of the thing that we did was because we fine-tuned the model using Hugging Face libraries. We used QLoRa, if anyone has heard. It was a very smooth ride with Hugging Face also, which is also provided for free. But then after we fine-tuned the model, we need to convert them to a slightly lighter and faster format, which came Llama CPP's help, like just one script, convert HF to GGUF, one Python script provided by Llama CPP, and we can convert it from the Hugging Face format to GGUF. And not only we convert them, this only converting already brings down the size, but then we can further quantize the model, make it even, like quantize here. Maybe it's similar to compressing the models without losing too much performance. And we have many options. In the end, we decided to use the 4-bit format. And as you can see here, like the size became so much smaller, and inference also became so much faster. And this all means when deploying in production, it means cheaper cost, which is a huge thing for, I think, a lot of companies that's serving like a lot of requests online. And what's good about this is it's not only that it's easy to use, but it can quantize the model, make it lighter, while retaining performance, which is what we appreciate a lot. And then not only quantizing the model, Llama CPP provided an already packaged Docker images for serving these models in production. And let me move forward to the next one. So after we prepared our models for production, we already quantized them, we are ready to serve them to the production traffic. But before we move forward, that we use another tool for load testing to make sure that it's really okay to release this model to our customers. And on this part, show here is an MLOps engineer who helped our team conduct this load testing. I'll give the mic to Show. Thank you.
Hello. Yes. Okay. Thank you so much. Yes, I'm sure. I helped Andre here deploy our model to our Kubernetes cluster, and also like before we deployed, we actually wanted to make sure that we can handle the load given the configuration that we have for the pods, basically. So here's where Locust comes in, where we were able to like mimic the amount of requests in production and directly use it for the currently deployed pods in development, so that we don't have to adjust on the fly once we release it, and also like not overshoot our configuration when we start releasing it. So yes, and more on Locust. It's an open source load testing tool where you can actually mimic an amount of users and requests given your given your custom scripts in Python. So it's a really cool tool. And yeah, basically like what we did there is once we deployed the Llama CBP deployment in our cluster, yeah, we started running the Locust script locally. We basically just created like simple like HTTP requests for the deployment, and yeah, connected it to our deployment on Kubernetes. And at first we started using just port forwarding, going through our API gateway. But then at some point we realized that this isn't too accurate, because like it also includes a latency of sending it from our computer into the deployments, right? So another way we tried after that is deploying Locust inside the cluster as well, so that basically we can try like what is the maximum request per second that it can handle without latency. Yeah, without the noise of the latency, right? And basically just, yeah, we adjusted the user count and the script even. And the good thing with Locust is you can even add delays inside for each request. So you can mimic like how many users and how many requests per second you're sending to the service. And the last thing that's really good with Locust is you have this really nice dashboard. It's a bit small, but feel free to like check out later. If you Google Locust load testing, it would show up, where you could actually visualize like what is the P50 latency, for example, and like how many requests per second. Are you getting a lot of errors as well? And you can even visualize like all the errors that happened, and you have the statistics of like what kind of errors were happening. Like are they 404s? Are they 500s, for example? So so yeah, and after that, basically after we found out that okay, given this configuration of how many T4 instances that we're using, this is the maximum amount of RPS that we can do. That's when we finalized actual deployment in production, and then we were able to deploy without any issues, basically. So yeah, giving it back to Andre now. Yeah.
Right. So yeah, thank you, Sho. So that's how we leverage both Llama CPP and Locust. And open source tools are a huge thing in our company. And this project that I just presented, it's not only the two of us who are working on it. It was a combined effort from everyone in the company. And not only Llama CPP and Locust, we are using a lot of other open source tools. So we're like, as a company, I think we're fully supporting the open source community, because it's been one of the strongest tools in our toolcase within the company to achieve what we want to achieve with our projects, to bring the best user experience for our customers. So yeah, I think that's it on our session. Thank you very much for listening. Do we have? Do we have time for questions? Or?
Okay, okay, okay. I will share the stream chat again. Hello, hello. Okay, okay, okay.
Okay.
Okay. Oh. Mhm. Okay. Mhm. Mhm. Okay.
Our final speaker this morning is Ipami Chicken.
Yeah.
He's an experienced data scientist with demonstrated history of working in the computer software industry. He's an AI researcher with the University of Technology.
Yes.
And today we'll be telling us about multimodal or large language model.
Okay. Hello, hello everyone. Nice to meet you, everyone. I'm the between Sipikon. I'm now an AI researcher at the Chulalongkorn Mahavidyalaya. Yes, Chulalongkorn University at the AI Foundry. And now, in this session, we will speak about the multimodal and large language model. How can we choose the model? What between LM or the multimodal? Say, okay, say yes. I'm not sure about. Okay, in the first, I think everyone can see the ChatGPT. In the 2023, so we have the ChatGPT after we develop on the GPT-3 to the ChatGPT platform. We build the LM process to the chat like the generative, but now why is not good? Sorry. Okay. From the LM, we can have the question answering just like the what's your name, and it can talk or answer you just like the question on the answering. Well, okay, my name is No, and I'm birth from the how do I know? But from now, and from the history, LM history, traditional NLP from the NCAM or the virtual and evolution to the deep learning, just like the IN or LSTM and attention mechanism. I think everyone can in the research field can see the attention or unit paper and its evolution to the transformer model, just like the birds or GPT and evolve to GPT-3. And in this present, we have the ChatGPT and GPT-4, GPT-4o. They have the next step on just like the Gemini, DeepSeek, just like on the open source model. And every model have the founder just like the transformer foundation have the encoder that can encode from the text based to the vectorized and vectorized that can find what how about information in the text or the NLP. And then you have the decoder that can generate or predict next word, next token that can generate what question, and it can answer just like the generative AI. and it can collage when you can scale up the transformer block, like we have the attention multi-head and focus to the feed forward, and we scale this, we can scale this transformer block, and now we use evolution from the decoder only. In the transformer decoder only is in the foundation of the LM in the presence like the GPT, Gemini, or the open source large language model. But now in the ChatGPT have evolution from the LM, and it have the some feature that's interest, just like the search engine that LM can search through the internet and reasonings. It can generate what about this question, and it can finding what the purpose of the question, or it can by the listening. Okay, in which question, what of your purpose, what of your objective, what it can find, or the 1 point to 2 point, 4 points, or in the in the in the in the below top, you can generate image from the ChatGPT, and surprise me brainstorm or analysis in image that can have the listening model. What about the create image? It can ask, you can ask from your question, and it can generate to your image. How can it solve this problem? Okay, from the options, we have an LM. You can ask him with your question or the text base, but now you can add the image input, and you can generate what your output. This process has like the vision language model that you can input from the text and image, and you can answer on the text base already. Sure, but if you add your sounds, just like from you can add the text, and you have add the image input, but now you can add multi objective, just like sound or the space to the LM, and LM can answer what your sound is like, or you can use LM like the speech to text, or anything about just like a voice assistant. This is process lifestyle and the model that evolution from the LM that can got the one input like text based to the output text based. But now we can add the input text based, image text based, and the voice text based, and evolve to next step. We have the any model, any model just like on the multi-model, we can add the text, image, speech, and generate to text, image, and speech too. That's I. Okay, but how LN understand a multi-agent or multi-objects? Okay, initially we have the image, speech, and video. Okay, from the image and speech video, you can use the model to convert object to the text based. That's like the image captioning or the speech recognition or video captioning to find the describe of this object, and this object can add to the LM with your prompt or create your question. You can use the question answering with your virtual VQA or the speech QA. So and it can LM can ask you, oh hello, this is multi-model. So and now in the first generation of the multi-model, you have the image with the model like image captioning to translate from the image to the text, and speech to speech recognition or ASR to transcribe from the speech to text based, video to with the video captioning to add to the LM. This is first generation of multi-model. And now we have the paper multi-model language model. In this paper is the focus on how can we add the open source model like the image encoder, like the image captioning, audio encoder, video encoder to the LM. That LM you can find for on the open source model and image encoder. And we have the generate output like the image, video, and audio in the diffusion base. So in the open model, you can find it on the Hugging Face tool, on the GitHub tool, and you can plug it together. Yeah. In LM, yes, you can find like the open source model like function beta in the Thai base or the Typhoon tool, and we have the Open Thai GPT tool. Yeah. But how can we plug between encoder object and the LM? So we can use some projection model from between encoder process and the LM process. That projection have meaning just like the linear model or the neural network, so that you can pass by the vision encoder. What about your shape on your model? That projection can process from your shape of output vision encoder to the input large language model, and large language model can have the feature like the language instruction or the prompt, just like question answering. And if you have add your vision encoder, it will evolution from the LM to the vision language model too. This is the paper from the Rama. Yes, oh no, sorry. This paper from the Lava. Lava is a paper from your Meta company that you have the vision encoder like the clip model, and use face model as a clip and pass to model as projection that pass video vision encoder like vision encoder shape to the image encoder onto language model and pass to VQA, that like that. And we can fine tune. Yes, we have the 3 step on the VQA or the multi-model as the G step. On G step, in step 1 we have the encoder, step 2 we have the projection, and step 3 we have the LM. So in this paper of the Apollo bench, the finding from the researcher in the encoder, we in this paper it is select from the face the encoder and fine tune on the projection and fine tune from the LM. In this remark is success from the 2 step, like the face encoder and face LM and train only projection. And step 2 after it had bottlenecks, it's train projection and LLM too. But if you have some GPU so much more than the Lava, you can finding on the Apollo bench, like in the first step you face encoder and LLM and fine tune only projection, and the training step 2 you train encoder and projection, and 3 step you train only the projection and LM. That can make the best score from the guideline of the Apollo paper that you can go to reference this paper too. Okay, and now we have the Quen 2 VL, Quen 5 VL. Quen 5 VL we have the vision language model that evolution from the LM, and they have the vision encoder. Vision encoder that got the image encoder and the video encoder too, and it can use the decoder only on the transformer base that use. This is open source model that you can use it too. In the Quen 2.5 we have 3 steps on the training, like the step 1 and the pre-train only the image questioning. Yes, and step 2 is use multimodal, and stage 3 have a long context tool. And we have the Quen 2 audio that pre-train from the audio encoder and pass to the Quen LM. That's audio encoder that got from the open source model, and Quen LM like the LM based model too, same. Yes. And now in the NU2NA model, we have the DeepSeek model has a model the GenAspo, so that you can input from the multi object like the encoder and with the text tokenizers, and it can generate next output what tokens about the auto-recursive can output from the image decoder tool, audio decoder tool, and the video decoder tool. That's so this is the last model that you can generate from the text based or the image based or the audio based like this. And how about the lag? If you using the LM, you can develop a visual lag model or the multi lag, just like this. This is the lag process that you have the two process on the collection data from the text. You can use the text embedding for send the text to the vector and collection to the vector DB. If you want to query them, you ask him with the text embedding, and it can finding with the similar search, and it use the LM to generate from the query to the next step. But now we have the multi-modal. You can add the multi-modal lag like the user like the multi-embedding for encode from the multi-object like space, video, or the image to the vector database, and you can add with your question to the query. I want this word with your image, and from this input or query, it can vectorize with the multi-embedding the same model to the similar search and query them from the vector DB, and from a multi-language model, it can talk to, okay, sure, this is your bird with your image too, the same. Okay, if you interest on the multi-modal like visual, what should we select from the what should we select the multi encoder? You can use visual document like benchmark this model. In the first, we have the business AI or the Cochrane tool. Okay. And in question that you have your problem, you have problem with your input multi, like the image, videos, or text, that you use the multi-modal. But if not, you have the same input like the text based, or you can use LM, or you can call API like GPT, Gemini, or your model on the base log or the database based on any model that you can use the LM or use the API based. But now if you want to fine tune the multimodal, you have many GPU and many costs per them. That's if you have the researcher tool. And if you want, you need to try agentic AI. We can see next time. Okay. Okay. Go. Thank you so much, everyone. Thank you. Thank you so much. Yeah. Yeah.
Thank you. That's all for this morning session. Please have a